What's up guys, this is Masi. Welcome to another video. In this video I want to talk about solubility. The first example here I have, it says, will a precipitate form when 100 milliliter of 4.0 times 10 to the power of negative 4 molar MgNO32 is added to 100 milliliter of 2.0 times 10 to the power of negative 4 molar NaOH. So we need to see that if we form precipitate or not. You know, whenever Q is greater than KSP, then we will have precipitation. So what we need to do, we need to write the MgOH2 in solid form. When it dissolves, it's going to produce Mg2 plus in aqueous phase plus 2 hydroxide in aqueous phase. So KSP will be the concentration of Mg times concentration of hydroxide to the power of 2. KSP will be equal to, when you read it from the table, is 8.9 times 10 to the power of negative 12. Now let's find out the concentration of these two. The concentration of Mg is 100 milliliter divided by 100 plus 100 times the concentration of Mg was 4 times 10 to the power of negative 4. That will be 2 times 10 to the power of negative 4 molar. Hydroxide will be 100 divided by 100 plus 100 times the concentration of NaOH, which is 2.0 times 10 to the power of negative 4. That will be 1 times 10 to the power of negative 4 molar. So Q will be Mg2 plus times OH to the power of 2, which will be 2 times 10 to the power of negative 4, 1 times 10 to the power of negative 4 to the power of 2. That will be 2 times 10 to the power of negative 12. Now if you compare it with KSP, KSP is 8.9 times 10 to the power of negative 12. Q is 2 times 10 to the power of negative 12. So as you see here, Q is smaller than KSP. So it means that will not precipitate. So no precipitate forms in this condition. Next example, it says a solution contains 1 times 10 to the power of negative 5 molar of Ag and 2 times 10 to the power of negative 6 molar Cn. Will AgCN precipitate or not? The KSP for AgCN is 2.2 times 10 to the power of negative 12. So AgCN is silver cyanide. In solid form is going to dissolve and produce Ag plus in aqueous phase plus Cn minus in aqueous phase. So Q will be equal to Ag times Cn, which you have both concentrations. 1 times 10 to the power of negative 5, 2 times 10 to the power of negative 6. That will be 2 times 10 to the power of negative 11. So this is KSP, this is Q. Q, as you see here, is greater than KSP. It means that AgCN will form as a precipitate because Q is greater than KSP. Let's see another example. It says a solution is prepared by mixing 100 milliliter of 1 times 10 to the power of negative 2 molar of PbNO32 and 100 milliliter of 1 times 10 to the power of negative 3 molar of NaF. Will PbF2 precipitate? The KSP of PbF2 is given as well. So PbF2 is the solid. When it dissolves, it's going to produce Pb2 plus in aqueous phase plus 2 fluoride in aqueous phase. So what we have, based on this formula, Q will be equal to the concentration of Pb times concentration of fluoride to the power of 2. So what we need to do, we need to find out the concentration of each. Concentration of Pb is 100 mixed with the other 100, so 100 divided by 100 plus 100 times the concentration of lead nitrate. PbNO32 is lead nitrate, which is 1 times 10 to the power of negative 2. So that will be 5 times 10 to the power of negative 3 molar. Next one is fluoride. Same thing, because the other one doesn't have fluoride. We just consider the concentration of sodium fluoride. That's going to give us 5 times 10 to the power of negative 4 molar. So Q will be 5 times 10 to the power of negative 3 times 5 times 10 to the power of negative 4 to the power of 2. So that's going to be 5 times 10 to the power of negative 3, 25 times 10 to the power of negative 8. That's going to be 125 times 10 to the power of negative 11, or 1.25 times 10 to the power of negative 9. Which, if you round it, is going to be 1.3 times 10 to the power of negative 9. Now we need to compare it with the KSP. KSP is 4 times 10 to the power of negative 8, and the number we got is smaller than that, so Q is less than KSP. It means that will not form a precipitate. So there will be no precipitation formed during this reaction. So that's how we figure out if we have precipitation formation or not. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.